Good day, everyone. So, our topic for today is stoichiometry, that includes mole to mole concept, mass to mass concept, and mole to mass concept. I am Dr. Erwin R. Abrencilio. So, for our learning outcomes, first, explain what stoichiometry is. Second, determine ways in solving problems about stoichiometry. And third, solve problems involving stoichiometry. So, for our lesson outline, so first, we will be having our short review and introduction of the topic. Then it will be followed by the concept and computation for mole to mole. So that is mole, which is converted to mole, and mass to mass, and mole to mass. So let us now begin with the review. So it is said that molar mass is known to be as the sum of the atomic masses of all atoms in a molecule. So atomic mass can be found in the periodic table of elements. So for example, um, in in an in a molecule of water, H2O, so there are two atoms of hydrogen and one atom of oxygen. So molar mass is the summation of the atomic mass of hydrogen plus that of oxygen. We also have this concept about molecules and moles. So a molecule is the smallest unit of a substance, and a mole is Avogadro's number, which is equivalent to 6.022 times 10 to the 23rd power molecules of that substance. So later on, we will tackle a little bit of this topic, though it is just a review. So balance equations, on the other hand, it is a chemical equation that must be balanced. So we all know why we should balance chemical equation. So number in front of a formula, or known as the coefficient in a balanced chemical equation, represent the number of moles of that substance. So later on, we will give some examples of this balance equation, and then we will identify the number of moles. So let us proceed to the molar mass. So it is the mass of one mole of an element or a compound. So it is the atomic mass expressed in grams, which are all found in the periodic table. So on the illustration on the right side of your screen is an actual mass of a carbon element. So that is 1 mole of C atoms, or 1 mole of carbon atom is equivalent to 12.01 grams of carbon atoms. And that is also equivalent to 6.02 to the 22 times 10 to the 23rd atoms of carbon. So that means that in 1 mole of carbon, there are 12 grams of carbon, which is equivalent also to 6.022 times 10 to the 23rd atoms of carbon. So these are some examples where you can find the atomic mass of certain elements. So the molar mass is the atomic mass unit, or the AMU, expressed in grams. So for example, you have there 1 mole of silver is equivalent to 107.9 grams, which is the atomic mass unit of the atom silver. Then for carbon, it is 1 mole of carbon is equivalent to 12.01 grams, which is that atomic mass unit of that element carbon. And another one is sulfur, that 1 mole of sulfur is equivalent to 32.07 grams, which is also the atomic mass unit of sulfur. So this is true also to the other elements. So the mass is located just below the element symbol on the periodic table. So formula mass of a compound, the formula mass of a compound is the sum total of the molar masses of all of the elements in the formula. So for example, calculate the molar mass of CaCl2, or calcium chloride. So first, you have to write the chemical formula. No? So in this case, we have CaCl2 and then determine the number of moles. So for calcium, you have their Ca1 because as we all know that if there's no number or a subscript for the atom, it is automatically 1. So it is 1 times 40.1 gram per mole, which is the atomic mass unit of calcium. So 1 times 40.1 is 40.1 grams. So for Cl, there are 2 mole. So 2 mole, 35.5 gram per mole. So cancel out yung gram, yung mole. So you can be able to get 71.0 because there are 2 mole for that. So all in all, you have a total of 111.1 grams for the total mass of calcium chloride. Okay? So for your first activity, I want you to answer the following. So determine the molar mass of the following compounds. So one is PCl5 or potassium, phosphorus penta chloride. Then you have their ammonium hydroxide, magnesium bromide, potassium chloride, and zinc phosphate. So let us again recall. So we are not yet in the main topic. We are still in the recall. So what is a mole? So matter is composed of atoms, molecules, and ions. So as we all know, no. So atoms are the smallest particle, and as Democritus said, it can no longer be broken into pieces. But we all know that atoms, as they grow bigger and became unstable, it can be cut. Of course, as atoms combine, they form molecules, they form compounds, and then they are also forming ions. So this is an extremely large number of them in a small sample of a substance. So counting these particles is not practical. So for example, you are to count the number of atoms of, let's say, 5 grams of water or 250 ml of water. So how are you going to count that? So for bigger objects, it is easier. So for example, count the number of eggs in one tray or count the number of people in one room. So it is easier for us. But if we are talking about the molecular level or even the atomic level, it is quite difficult. So yeah, think about counting eggs down. So it is easier when the eggs are grouped into dozens. So a dozen is a specified number 12 of things. So for example, 1 dozen of eggs, 1 dozen of people, 1 dozen of bread, 1 dozen of this and that. So automatically that is equivalent to 12. So how about counting with moles? So chemists also use a unit that is a specified number of particles, most often atoms or molecules, and that is known as the mole. No? So mole is a substance which is equivalent to 6.022 times 10 to the 23rd or representative, sorry for that, representative particles of that substance. So it could be an atom, it could be a molecule of, let's say, of carbon, of sulfur, or any element. So the number of representative particles in a mole, and it's called Avogadro's number, which is equivalent to 6.022 times 10 to the 23rd power. So the unit could be 6.022 times 10 to the 23rd atoms or 6.022 times 10 to the 23rd molecules and so on and so forth. So, for example, magnesium is a light metal used in manufacture of aircraft, automobile wheels, and tools. How many moles of magnesium is 1.25 times 10 23rd to the 23rd power atoms of magnesium? So, first is you have to analyze the given, right? So, your given is the number of atoms of magnesium, which is 1.25 times 10 to the 23rd atoms of magnesium. So in that case, first is you have to list the unknown. So, and listing the known and the unknown. So known, you have the number of atoms, which is equivalent to 1.25 times 10 to the 23rd atoms of magnesium. And for our conversion factor, 1 mole of magnesium is equivalent to 6.022 times 10 to the 23rd atoms of magnesium, as stated in the previous slide. So what's the unknown? Your unknown is what is being asked in the problem. So moles of or number of mole of magnesium. So first is you have to use the dimensional analysis to solve for the unknown. Drag and drop a unit and chemical symbol. So you have here 1.25 times 10 to the 23rd atoms of magnesium, and that is equivalent to 1 mole of magnesium as stated in the previous slide. And 1 mole of magnesium is equivalent to 6.022 times 10 to the 23rd atoms. So make sure that it is located or positioned at the bottom part, as we all know that numerator can be able to cancel out denominator. So that means one should be on top and the other one should be at the bottom. So so that you can be able to cancel the number of the word atoms of magnesium because you are looking for mole of magnesium. So 1.25 times 10 to the 23rd to the 23rd divided by 6.022 times 10 to the 23rd, you can be able to get 0.208 mole of magnesium. So as simple as that. So converting moles, atoms, or molecules. So for example, propane is a gas used for cooking and heating. How many atoms are in 2.12 mole of propane? By the way, the shorthand or the shorter name for moles is MOL or mole. So the chemical formula for propane is C3H8. So again, the same procedure. Write the known and the unknown. So number of moles is 2.12 mole of C3H8 or propane. And then conversion factor natin, 1 mole C3H8 is equivalent to 6.022 times 10 to the 23rd molecule of propane. So 1 molecule is equivalent to 11 atoms because there are 3 carbon atoms in the molecule and then 8 atoms of hydrogen. So what you're looking for here is the number of atoms. So in this case, you have here, there you go. So 2.12 molecule, 2.12 mole of propane over 1 times 6.022 times 10 to the 23rd molecules of propane for every 1 mole. And then there are 11 atoms for every molecule of propane. So with that, you can be able to cancel a mole of C3H8, then molecules of C3H8. So at the end of it, the last unit that will be retained is only the atoms. So when you solve it, 2.12 times 6.022 times 10 to the 23rd. Well, of course, if you are going to divide that with 1, the answer will remain the same. So that is equivalent to 1.4 times 10 to the 23rd to the 25th atoms, right? So in that case, let us proceed now to the next. So counting atoms in a molecule. So how do we count the number of atoms in a molecule? So for example, you have there the chemical formula, ammonium phosphate. So in that equation, and I'm sure that you have learned this in our previous discussion about a chemical equation. So you have there 3 nitrogen atoms, 12 hydrogen atoms because there's quantity 3, no? So 4 times 3 is 12, and 1 phosphorus atom, and 4 oxygen atoms. So in 1 mole of ammonium phosphate, there are 3 moles of nitrogen, 12 moles of hydrogen, 1 mole of phosphorus, and 4 moles of oxygen. So it is very essential that you will know this because these are needed in the next discussion about stoichiometry. So for your next activity, I want you to solve for the unknown for each of the following samples. Number of atoms of each element for ammonium sulfate and number of molecules of zinc with 2.54 times 10 to the 14th atoms. Okay, so you can just go back to this slide if you would like to answer this activity. So let us now proceed to stoichiometry. So it is the process of using a balanced chemical equation to determine the relative masses of reactants and products involved in a reaction. So scientific notation can be used for the masses of any substance in a chemical equation. So what you should understand first here in this particular topic is that you should have understand balancing of chemical equation or even how to write a complete and balanced chemical equation because if you cannot write a complete balanced equation, then therefore you cannot solve any of the problems involving stoichiometry because the first very step in solving stoichiometry problem is to complete and balance the chemical equation because everything matters in the chemical equation. You need to get the mole ratio. It will you will get that in the chemical equation. You have to get um, the number of mole. Then you have to go back to the chemical equation. So if your chemical equation is incorrect, then therefore the rest will also be incorrect. So, a mole ratio is a conversion factor derived from the coefficients of a balanced chemical equation interpreted in terms of mole. In chemical calculations, mole ratios are used to convert between a given number of moles of a reactant or product to moles of a different reactant or product. So, as I've said, you have to write a correct and balanced chemical equation so that you can be able to identify the mole ratio because the mole ratio will tell you how to solve for the unknown in your problem. So for example, so um, all right, look again at the balance equation for the production of ammonia. You have here N2, H2, and the product is ammonia. Okay, so the three mole ratios derived from the balance equation above are in 1 mole of N2, you'll have 3 mole of H2. In 2 mole of NH3, you'll get 1 mole of N2. In 3 mole of H2, you'll be able to get 2 mole of NH3. So that's the mole ratio. So if you cannot write a correct um, and balanced chemical equation, how can you be able to make a correct mole ratio? Okay, so let us proceed now to the first calculation, which is mole to mole. So mole to mole meaning if the given is in mole, the answer could also be in mole. So in the mole ratio below, W is the unknown, or what we call as wanted quantity, and G is the given quantity. The values of A and B are the coefficients from the balance equation. So we will be using these variables in the general equation for the next slides. So the general solution for a mole-to-mole problem is given by um, mole G, no, that is already cancelled out. So B mole of W is equal to XB over A mole of W, or Um, X mol G is the given actually, and then B mol W over A mol G is equal to XB over A mol of W. G is the given, W is the 110. Okay, so let us now proceed here. So calculating moles of a product. So how many moles of ammonia are produced when zero point 0.6 mole of nitrogen reacts with hydrogen? Do you still remember the equation a while ago? So that is the same equation in this particular topic, problem. So first, analyze less than known and the unknown. So the conversion is mole N2 to mole of ammonia. Okay, so 1 mole of N2 combines with 3 mole of hydrogen to produce 2 mole of ammonia. So as you can see here in the illustration, no, um, let us highlight. So you have here, this is N2, and that is this one. So 1 mole of N2, okay, and then this is the 3 mole of hydrogen that is written in this part, and then you have here that produce 2 mole of ammonia, and this is this one. Okay, so all this 1 mole of N2, 3 mole of hydrogen, and 2 mole of ammonia are all essential when it comes with the mole ratio. So you have to write the known moles of nitrogen from the given in the problem is 0.60 mole of N2. And then the unknown is the moles of ammonia. Right, so let us proceed. So first, the second step is to solve for the unknown. So I have included here again the chemical equation. So write the mole ratio that will allow you to convert from moles N2 to moles of ammonia. So again, let us highlight. So this ratio came from the your balance equation. So again, this is a balance equation. So you have here 2 mole of ammonia, and this is this one, and then 1 mole of N2, this one. Okay, so let us continue. So the next step is to solve for the unknown. So multiply the given quantity of N2 by the mole ratio in order to find the moles of NH3. You might ask, why is hydrogen not included? So simply because it is not part of the problem, though it is part of the equation. So you cannot arrive on the answer if you will include in the computation the number of mole of hydrogen. So you have here 0.60 mole of N2, which is from the given. Then we'll get the mole ratio. So it is 2 is to 1. You might ask, why is it 2 is to 1? Why not 1 is to 2? If you are going to put 1 mole of N2 on top instead of as a denominator, you cannot be able to cancel mole of N2. So you have to remember that the positioning of the ratio will depend on how you are going to cancel it. So 0.60 times 2 is 1.2 mole of ammonia. Okay, so remember that the mole ratio must have, yeah, the one that I explained a while ago, must have N2 at the bottom so that the mole N2 in the mole ratio will cancel with mole N2 in the node. Okay, so third is evaluate. Does the result make sense? So the ratio of 1.2 mole NH3 2.60 mol and 2 is 2 is to 1 as predicted by the balance equation. Why? Our our ratio is 2 is to 1, okay, and our mole of ammonia is 1.2. Meanwhile, N2 into mole is 0.60. Okay, so 0.60 actually is when you duplicate that. So that's why it's 2 is to 1. So 0.60 is 1 for N2 and 2 for ammonia. So that is 0.60 times 2. So you'll be able to get 1.2. So it is actually an easy problem. And all of these are also easy, provided that you have to follow the step-by-step no, process. And again, the one that is crucial is the balancing of equation. Okay, so let us proceed now to mass to mass. So in the laboratory, the amount of a substance is usually determined by measuring its mass in grams. If a given sample is measured in grams, then the mass can be converted to mole by using the molar mass. So that is mass to mole. So the mole ratio from the balance equation can be used to calculate the number of moles of the unknown. And if it is the mass of the unknown that needs to be determined, the number of moles of an unknown can be multiplied by the molar mass. So there are several possibilities. No, so these are the different equations that you might encounter as we solve problems for this particular concept, mass to mass. So first, change the mass of G. G is the given to moles of the given. So that means mass to mole of the given by using the molar mass of the given. So mass of the given times 1 mole of the given over molar mass, you can be able to get the mole of the gram of the given. So for example, you have there, let's say, sodium chloride. So what's the, let's say, 5 grams of sodium chloride. So what's the molar mass of sodium chloride? Diba? The unit of the molar mass is gram per mole. So that you can be able to cancel out the gram, then the gram should be at the bottom, no? And at the end of it, you can be able to get mole as the last unit. Okay, so that mole can be used to convert the mole of the wanted. Okay, so provided that you'll follow the general equation. And then the third one is change the mole of the wanted to grams and then by using the molar mass. So that in that case, you can be able to get the mass of the wanted. Okay, so this is the flow chart. No, it is a figure, although it is the same as the explanation in the previous slide. So the figure below shows another way to represent the steps for doing mole to mass and mass to mole stoichiometry calculations. So for a mole mass problem, the first conversion is skipped. For a mass mole problem, the last conversion is skipped. So in this example, though we are talking about mass to mass, it is also being shown the conversion for mole to mass and mass to mole problems. So let us now proceed here, calculating the mass of a product. So with the same, no, same equation. So calculate the number of grams of ammonia produced by the reaction of 5.40 grams of hydrogen with an excess of nitrogen. So the balance equation is N2, 3H2 produce 2 NH3. So same step. list the known and the unknown. Now, I have also to double check the balance equation if it is really balanced. Do not just rely on the saying that is a balance equation. So you have to double check it. So reactants to nitrogen, product to nitrogen, reactant hydrogen 3 times to 6, 2 times to is also 6 for the product. So what are the knowns? So mass of hydrogen is given. You have also the different mole. So 3 mole of H2 is equivalent to 2 mole of ammonia from the balance equation. And 1 mole of H2 is equivalent to 2 grams of H2. Why 2 grams? Because the atomic mass of hydrogen is equal to 1. So 1 times 2 is 2. Now, for the molar mass of ammonia, so for hydrogen, it is 3. No, for nitrogen, it is 14. So 14 plus 3 is 17. So that's the molar mass of ammonia. So for the unknown, it is actually the mass of ammonia that is being asked. So list the knowns and the unknown. So the mass of hydrogen will be used to find the mass of ammonia. Okay, so grams of hydrogen and the gram of ammonia. So the coefficient of the balance equation show that 3 mole of H2 react with 1 mole of N2 to produce 2 mole of ammonia. So let me show it again to you. So this one, 3 mole of H2 reacts with 1 mole of N2. So this is that one. And producing 2 mole of ammonia. And this is the 2 mole of ammonia. Okay. So we have the following steps that you should follow. So first is the gram of H2. Okay, so this is the given. And then the mole of H2, given already. And then mole of ammonia. And then gram of ammonia or mass of the ammonia. Okay. So the next step is to solve for the unknown. So start with the given quantity and convert from mass to mole. So the given quantity is the mass of hydrogen. So change given unit to mole. So again, this is the molar mass of hydrogen. So that you can be able to get the mole no, of hydrogen, convert it. No, so to 5.40 divided by 2. So later on. And then you have to use the molar ratio of ammonia and hydrogen. So that is 2 is to 3 based on the chemical equation presented a while ago. And then you have here 17 gram of ammonia for every 1 mole of ammonia. So that is gram per mole. Okay. So this is 2 to 3, this one. And then the 17.0 is the molar mass of ammonia. Would be the formula mass, formula weight. They are both the same. So when you follow the solution, which is 5.4 times 2 times 17 divided by 6, so you can be able to get 31 grams of ammonia. Okay, so the next step is to evaluate the result. So does the result make sense? Okay, so because there are 3 conversion factors involved in the solution, it is more difficult to estimate an answer, which is correct, no? Because the molar mass of ammonia is substantially greater than the molar mass of H2, the answer should have a larger mass than the given mass. The answer should have two significant figures. So in a typical stoichiometric problem, so the given quantity is first converted to mole. So let's say 5 grams of water, convert that to mole. All you have to do is to get um, the molar mass of water and then multiply it so that you can be able to have mole. Then the mole ratio from the balance equation is used to calculate the number of moles of the wanted substance. And the moles are converted to any other unit of measurement related to the unit mole as the problem requires. So, this one naman is the mole to mass relationship gives you two conversion factors. So one is 1 mole over molar mass and molar mass over 1 mole. So that depends upon on which one you are going to cancel. So recall that the mole can be related to other quantities like 1 mole is equivalent to 6.02 times 10 to the 23rd particles. It could be atoms, it could also be molecules. And 1 mole of gas is equivalent to 22.4 liter at STP. STP means standard temperature pressure. So this provide four more conversion factors, which is 1 mole um, equivalent to 6.02 times 10 to the 23rd particles and 6.02 times 10 to the 23rd particles over 1 mole and 1 mole over 22.4 liter or 22.4 liter over 1 mole. Right. So this is the one that summarizes the steps for a typical stoichiometric problem. Okay. So these are the data that you need. However, for each concept like mole to mole or mass to mass or mole to mass to mole, I have indicated here also some problems. So calculating the molecules of a product. Again, molecules is different from mole. So how many molecules of oxygen are produced when 29.2 grams of water is decomposed by electrolysis according to this balance equation? So our balance equation is 2H2O form 2H2 plus O2. Okay. So again, first step is to analyze and list the unknown. The following calculations need to be performed. We have there the given, the mass of water converted to mole of water to mole of oxygen, and then to molecules of oxygen. So our mole ratio is 1 mole of oxygen for every 2 mole of water. So mass of water is 29.2. 2 mole of water is equivalent to 1 mole of oxygen. So that came from the balance equation. And 1 mole of water is equivalent to 18 grams of water, which is the molar mass. It came from the summation of 16 for oxygen and then 1 times 2 for hydrogen. So you'll be able to get a total of 18. And then, of course, 1 mole of oxygen is equivalent to 6.02 times 10 to the 23rd molecule. And then, of course, the unknown is the molecules of oxygen. So calculate and solve for the unknown. So 29.2 grams times 1 mole of water over 18 grams of water. So this is the molar mass, so yung gram per mole. So change it and then insert the mole ratio. So for every 1 mole of oxygen, there are 2 mole of water. And then since you are looking for molecules, then multiply it to the number 6.02 times 10 to the 23rd molecules of oxygen. And then at the end of it, you can be able to get 4.88 times 10 to the 23rd molecules of oxygen. So just imagine just for 29.2 grams of water, there are 4.88 times 10 to the 23rd molecules of oxygen. So does the result make sense? Yes. So the given mass of water should produce a little less than 1 mole of oxygen or a little less than Avogadro's number of molecules. So the answer should have three significant figures. All right. So for your activity 5C, solve for the following. So you have here the first one. Um, these are not yet balanced. So that's why one of the questions is that you have to write the balance equation or you have to balance the reaction, write the mole ratio, and then solve for the unknown. So for number two, the same but different um, chemical equation. And then for the third one, the same but different chemical equation. Right? For the references, these are the different sources. And thank you so much.